Greetings everyone who is doing my internship presentation at the moment. This is Udit Bahari and this is a video presentation of the internship report which I generated during my internship at the College of Aviation Technology. The internship was from 2 May to 3 June and I wish to present my report along with the experiences which I have done during my internship time. So my internship title was Lithium Ion Concept and Design, where I studied the application of lithium ion batteries in vehicles and also the general working of them. So let's just start it. All right. So first we have the introduction. Lithium-ion batteries are basically the most popular kind of batteries we have in the moment. The only reason we are able to have powerful microchips in our pockets at the moment are due to these batteries. And these have a certain technology. These are certain reasons why lithium is picked. One of the reasons is that lithium is the lightest metal and it has a very high electrochemical potential. So it was most suitable for a battery. In introduction in the context, we also have the how the technology is expected to play a crucial role in designing mobility of the future. And this is going to be the main focus of my further part of the report as we need to focus on implementing the lithium-ion technology into the future of vehicles. Let's just move forward. So here we have a Gantt chart of my internship, which I had prepared, which lists all the activities and experiences which I have done divided in particular weeks. So as you can see, in the first week, which started from 2nd of May to 6th of May, I studied about the introduction, background of lithium battery and the aims, objectives and synopsis. So basically the beginning part where I didn't even know how the battery works and what I have to do. The entire week was spent on that. The background of lithium batteries is a very large concept and it's a very large information which I had already included in my internship report. I have not included it here, but I have studied about it a lot. And the aims, objectives, and synopsis are written below as to so I can understand that what I have to do. I have followed up with my professor about this concept weekly, and he helped me go through it all and helped me understand what all I have to research and what all I don't have to research. So as we can see in the synopsis, this internship report is about how lithium-ion technology will be implemented in the future of flying. A basic understanding of working of technology is achieved and design specifications of such urban air mobility vehicles are explained. An urban air mobility vehicle. This is a concept of the future which has been discussed on since the past, but it's a very exciting concept and it's closer to us than it seems. Study claims that by 2024, Dubai might be able to implement this urban air mobility technology for the public, and it's just wonderful. Moving on, we have the principle and design of a lithium-ion battery. So this was the part where I learned about the battery. This was my experience part of my internship, or as you can say, it was the discovery part of my internship too, as I say, well, work experience discover. So the experience and discovery was this part. I had to learn about how lithium-ion battery works, and basically, it's a very interesting concept. It's a very simple concept, which consists of an anode, cathode, separator, electrolyte, and two current collectors. The entire process is mentioned here. I had first studied about all this and then written this down. So the lithium-ion battery consists of largely four main components: the cathode, anode, electrolyte, and separator. Just like a normal battery, the thing which was special about this battery is that since it contained lithium and it had a high electrolytic potential, it was able to power literally from small mobile phones to large vehicles. Current gen electric cars are also powered by this battery, and this is a technology which is currently getting involved further and further, and this can be the technology of the future. Moving on, we have some information about the lithium-ion battery, some other applications like why it is preferable in most electric vehicles as it is a high energy density. So it was really possible due to its high energy density to make the battery size smaller, because if we would have taken any other element for the battery, then the size specifications which are required to like fit a handheld device or a car would not have been able to achieve. Now we move on the next concept of my internship report, which was the future of flying. powered by lithium-ion batteries. And this was a really interesting concept because when I was applying for the internship, I wished that it would, since it was an electronics internship, I really hoped that it would be aligning to my uh, aspirations as a future mechatronics engineer who has to work in mobility. And when I learned that I have to work on the future of flying, this just blew me away because it's a very, very interesting concept. So as we can see, an air taxi, which is literally a flying car, is a small commercial aircraft or a helicopter for short flights on demand. Intercity travel, intracity travel, anything such like that. It is considered as an alternative for travel in urban centers with congested roads and also called an urban air mobility vehicle. So the congested road parts. We as humanity, when we saw that we have a shortage of land and we had to build more workspace, see, we started building skyscrapers. We started using height to our advantage. So if we can do it for the purpose of stationary work, why can't we do it for the purpose of mobility? If we are knowing that there are a lot of number of vehicles in our land right now, and we need more land to cover for the growing demand of mobility, why can't we use the height? So that was the basic concept. All major automobile companies and property startup have already dealt in the urban air mobility market with Toyota, Hyundai, which has some big names, Uber, Airbus, and Boeing working together on the models. Further, we're going to be discussing about a particular model from Uber too. So according to Morgan Stanley research, the autonomous aircraft market is could be worked by nearly $1.5 trillion by 2040. Another study sees air taxis already in operation in Dubai as early as 2022. So, as I said, 2022 is going on, but an updated report says that since 2022, Dubai has some prototypes in motion, and by 2024, as I said, this will be available to the general public. So I talked about Uber. So let's just focus on Uber at the moment. Uber Elevate is the name of Uber's internal team and initiative focused on launching their Uber Air product for the public. According to Uber, Uber Air is expected to fully launch sometime in 2023. And since Uber is a big giant in mobility market at the moment, it is surely to invest in urban air mobility too. And Uber Air is the main vertical at this point. So now we see the concept and design of an eVTOL, which stands for electric vehicle takeoff and landing. These are vehicles which have been somewhat shown in movies, shown in entertainment products, and these are coming in market right now. Defense has also been researching in this particular concept lately, and they have achieved quite a bit. The prototypes on the defense vehicles for the eVTOLs are already out there. And now we are focusing on providing this technology to the general public. Developing batteries for electric vehicles has been a challenge. Researchers have to worry about their weight since they have to fly. They must deliver very high power while the vehicle moves vertically during takeoff and landing. And that's where the lithium-ion batteries comes in because, as I said, lithium-ion batteries, since they have a large electricity and energy density, they can be applicable with a small size. All right, let's move forward. Design of Uber's ECRM003 eVTOL. Now I wanted to include the design of a particular prototype in action to my report so as to elaborate further. And the design of choice was my Uber's ECRM003 VTOL. And this basically covered the basic design and how it looked. So like I said, one can notice the Uber standard of incorporating high wings, which will provide some shade and or light rain protection as passengers on board. So we are at this point where we're not just focusing on getting the thing off the ground, we're also focusing on comfort. We're also focusing on productivity. So as to get it in the market as soon as possible. The entry and exit doors are on the side of the aircraft to reduce confusion of practice passengers and the ground crew. As I said, Uber is really working on getting this thing into the market at the moment, and they are perfecting everything for the moment for this ECRM003 eVTOL. We also have some positions like while boarding or deplaning, all propellers are stopped and the co-rotating propellers are parallel with the booms and fuselage. So passengers and crew will not have to duck their heads to miss them. As I said, this entire paragraph will state how the Uber's ECRM model has considered every little possibility into detail so as to provide comfort to the customers. We have some more information about the ECRM003. So one main thing about the Uber's ECRM003 is that it has a DEP technology, which is the distributed electric propulsion technology. It simply means that multiple engines are distributed at different parts of the plane. For example, along, above, below, within, or around the wings. Using DEP, we can achieve better performance from the aircraft, including improving the flying capability in normal and bad weather conditions, along with improving the flight control. Since we have multiple engines propulsion in different directions, we can control each of them to provide for a more custom kind of flight, which is seen in helicopters. As helicopters have more mobility, more close range mobility than a particular big airplane. Let's move forward. We have some design specification of the Uber ECRM 003. The aircraft type is eVTOL, pilots 1, passengers 4. So it will be accommodate as many people as a normal size car. It will be an all electric flight and it will have 9 propellers. We also need to have skyports, which will be similar to airports, except that it would be able to only store, it will require short land since these models are very small, and skyports will basically handle 1,000 flights per hour of these models and 4,000 passengers per hour, which will improve our mobility as humans to a really large extent, because we, as I said, we will be using sky as the limit. Let's move forward. As of June 2019, Uber has announced that it is working with 6 major aircraft manufacturers that are developing eVTOL aircraft specifically built for aerial ride sharing. These include Boeing, Bell, John Deere Mobility, Caram Aircraft, and many more. Uber Elevate also has an ecosystem partners including NASA, US Army Research Laboratory. As I said, the Army has been working on designing eVTOLs for defense since very long, because it's a concept which has been expected and which has been estimated to be working around 2024. All right, let's go. Now, in my Gantt chart, if you guys can remember, the last week of my internship was basically entire work week of my work discover experience project, and it was working on the conceptual design and specification for a lithium-ion battery for urban air electric vehicles. Now, we have learned anything. We have learned how lithium-ion battery works. We have learned its application. We have learned how we need to implement it in the future of flying. So the last thing was actual practical work on how to design a conceptual part. So the next slides will be focusing on that, and this took an entire week, as this was a personal thing. It had to be done by ourselves, and this was really informative because I had, since I'm from mechanical engineering background, I had learned about and many things like state of health of a battery and reliability of a battery, how our batteries are aligned, such concept which, if this internship wasn't there, I wouldn't have been able to learn in my curriculum. So let's move forward. Now, we had at the start 3 possible structures for the batteries, and these structures had different probabilities of success. As you can see, it's like designing resistors with different series to parallel configurations. Now, we have a graph which states probability and the probability for different structures, and A, B, C, D. Since in the last slide I showed these 3 different structures, A, B, C, D, these are the probabilities of the success for these different structures when we contain the battery packs in some similar series parallel M into X kind of manner. So now we had one more concept which had to be taken off, which was the state of health of the cells. The state of health was defined as a variable which reflects the general health condition of a cell and its ability to deliver specified energy or charge as compared to its fresh state. So basically, we take a cell into consideration, and state of health is basically a comparison of the cell's current health along with another cell which is completely fresh off the market and we haven't used it. It's basically used for determining how the health of the current cell is, and it's a big factor in designing the M into N type of configuration for cells in these vehicles. Now, this was some pictorial data which I had only included here, so to show how it works. We calculate the state of health for a lithium-ion battery for different arrangements with different coefficients at different temperatures, and I have also included their values at the same. Final conceptual design such a redundant cell will be as follows. Now, after all this, taking all these configurations into consideration, we had designed a prototype, or not a prototype, a basic generalized way of how the cells would be managed, because since it's an eVTOL, a simple 2 into 3 configuration wouldn't be sufficient. We had to take all variables into consideration. So we calculated probability density functions, we calculated state of health, we calculated everything just to get that particular configuration. It's like how we used to do problems on resistivity in our school days. How we used to be given a value of a particular resistance which we're trying to achieve, and how we had to design different configurations. I experienced that during my work for the internship, the work was similar. However, in this state, it was a much more practical and much more real based, since there were a lot of variables which had to be taken into this. So this was some data which I had collected. Now, like I said, if del M parallel and del N series branches are added to the bacteria, the discharging rate becomes. Now, del M parallel and del N series was M and N was the number of batteries in parallel and number of batteries in series. So it was a completely analytical approach, since I wasn't able to get my actual hands on. So I had to work on the existing formulas and existing analytical approach just to get the exact value of M into N and a relation between the M into N configuration with the desired reliability. Now, the reliability was a battery pack, which was the main concern. The reliability is the thing we check, and the reliability is the thing we are given while designing a battery. For example, if we're designing a configuration for resistors, we are given the resistance, the total resistance, and we had to work on it accordingly. The reliability works according to the same. If we had to calculate the reliability of the battery pack, let us set the failure threshold at W is equal to 80%. As it is common practice for lithium and batteries in EV applications. So, yep, we had also taken real world scenarios into place. It was not all just practical explanation. We also take failure, and reliability is basically how it would work in the real world scenario, because no electric component is perfect. So we had to configure everything. So the entire part of the design was to get in how to achieve a certain reliability with a certain number of cells, and what configuration do we need to have the same. All right, let's move forward. This is just the data part and the research part of my project. I had include some of the slides. This is not the entire slide of the design part, but this is some of the slides just to show how it all proceeded and how what I was trying to achieve. We established the reliability for two battery packs, first and second, with the state of health being 0.8402. And from this, then if we put n is equal to 1 and del n is equal to 1, we would be able to calculate the state of health of the batteries. We only calculate the reliabilities for the first and second battery pack so as to develop a relation between the desired reliability and how the cells are to be arranged. I have included the data, the reliability by discharging 800 cycle at 25 degree and 500 cycle at 50 degree, just to show the experimentation values which I had secured from the already taken experiments available to the public. Let's move forward. Simple calculations can be done for different del M and del N, and for the case of if the del M is equal to 1 and del N is equal to 1, that means 1 in series and 1 in parallel. That means that 8 cells are added to the battery pack and the configuration becomes 3 into 6 parallel series. This is completely analytical. We have not considered the experimentational values. We have just configured how to develop a configuration with an M into N series or parallel configuration so as to develop a reliability of 80%, which has been seen in the previous slide. We can find the battery pack configuration with minimum cells for the desired reliability with the figures given below. So after all the research, all we had to achieve is we had to develop a relation, as you can see in the graph at the bottom. We had to develop a relation between the battery pack configuration with the minimum number of cells, because when we are manufacturing anything, we are trying to achieve the minimum amount of material which we have to put in, and we are trying to maximize the output. So if we have said that we have to develop a desired reliability for the battery, then we design a configuration which will require the minimum number of cells. That's the entire target of our internship. So now we had the graph for the same with the A, B, C, D, and E, F configurations, and A being 2 into 5 configuration, D being 2 into 8, 3 being 3 into 5, D being 2 into 9. Basically testing of different configurations for desired reliability with the minimum number of cells. So moving forward, when we need to design a battery pack, if the battery pack is to be reliable, now battery is said to be reliable if its reliability is greater than 80% after being discharged and charged 800 times. So we are also taking into consideration that it works, it is still reliable after 800 charge discharge cycle, which is a very large life for such battery because they are very powerful. So we're not just taking into consideration the initial power or the initial aspect just to get the battery rolling up. We are also taking into consideration how it would work in the vehicle, because a vehicle is a big asset. It works for a long period of time. So for working a long period of time, we have to charge and discharge our batteries multiple times. So When we need to design a battery pack for a reliability of greater than 80%, we can select a 3 into 6 configuration, which will consist of 3 in series and 6 in parallel cells, total of 18 cells, which is the minimum number we can get for a reliability of greater than 80%. During the design of high reliability lithium-ion pack, we should consider both the configuration and the cell redundancy number, as the relationship between the reliability, the cell number, and the configuration pack is non-trivial. It's a non-trivial number, and which basically means that it's completely analytical and we can calculate it. Comparing the reliability of two battery packs at different temperatures, we conclude that the reliability could be improved by adding redundant cells as expected, but we also need to consider that we add as minimum number of cells as possible. So it's a basically clash. If we need to improve the reliability, we need to add more cells, but we are also trying to achieve the minimum number of cells so as to keep our cost low. So for a set 80% reliability, the most effective was a 3 into 6 configuration according to our research in this project. The proposed design concept provides a way to select the best redundant cells configuration for a good pack reliability while considering the total cost to the optimal number of usable cells. This was the basic concept of our research, and this was the thing which was able to achieve to develop a relation between the reliability and the configuration of cell while keeping the reliability as a minimum number of 80%, which is considered a reliable product, which is a high reliability, also keeping the number of cells low. But because as it is, and we know that reliability is directly proportional to the number of cells we take. So, but yeah, in the real world scenario, we need the minimum number of cells as possible. This concluded my conceptual design part of the internship, and this was actually really fun to know new concept about reliability of a battery and how for different applications. So, for example, configuration will be different for a lithium-ion battery designed for a handheld and lithium-ion battery designed for a car. So it was really interesting to know. And based on this information, I have been able to, I believe that I am enabled to design batteries for different cars as well as different vehicles just by calculating their reliability, desired reliability, and the state of health factors of the battery. Also, while keeping some other functions into place, which I have not included in this PPT, but universal value functions, etc., etc. Okay, so thank you everyone. My PPT has ended, and it was a great pleasure to be working with the College of Aviation Technology for this internship. And I am grateful for my professor who has enabled me to research so much about the project, and he helped me throughout the entire process. I had any doubts, and he was always willing up to help me. So it was a great pleasure, and this concludes my video presentation. Thank you everyone.